Welcome back. Now we're ready to start handling user input. That means we'd like to press the keyboard keys and move the mouse and click the mouse and see our tank react to that input. Now in order to do that, we first need to actually get that input, and we're first going to start doing that using axis mappings. So let's talk about this. Now here in the project, let's go to Edit and Project Settings. And if we scroll down and select Input, then we see our bindings here. And under bindings, there are action mappings and axis mappings. We're first going to get into axis mappings. Now, you may have some experience with these, but we're going to take a little bit of a deeper dive into what these do and how they work. So we have 3 of them. And if I click on the drop-down arrow, I'll see here W and S, and these are talking about the W and S keys on the keyboard. These are assigned to this particular axis mapping, which is called Move Forward. So let's discuss how this axis mapping works. So we saw in the Unreal Editor that we have this axis mapping called Move Forward, and it's got the W and S keys assigned to this axis mapping. So what does this mean exactly? Well, in Unreal Engine, we have something called an axis mapping. An axis mapping is something that's processed every single frame of the game. You assign keys to an axis mapping. In our case, we've assigned W and S. Now take a look next to the W key. Here in my little screenshot sample to the right, it says Scale, and next to Scale, there's a number, 1.0. And you may have noticed next to the S key, the scale is -1.0. So these are values that will affect that input information. Here's how an axis mapping works. Our axis mapping Move Forward has the ability to be associated with a function in C++. Now, when it comes to axis mappings, if we associate a function with an axis mapping, it needs to take an input parameter of type float. So we can create a function on our pawn called move that takes a float. We'll just call this input parameter value. Now there's a way to take this function and associate it with our move forward axis mapping. It's said that we bind the move function to the axis mapping. So every frame of the game, Unreal Engine's input system is going to check to see if we're pressing the W key or the S key, and it's going to compute an axis value depending on whether or not we're pressing those keys. And every single frame, it's going to call this function that we've bound to move forward and pass that axis value in. Whatever happens inside of that function is up to us as the C++ developer. Now here's how it works. If we're not pressing the W or the S keys, this axis value has the value 0. So the move function that's bound to the move forward axis mapping is called every single frame, and the float value passed in is 0. Now let's say we're pressing the W key. The W key has its scale set to 1.0. This means that our axis value is going to be 1.0, and that's what gets passed into the move function. So every single frame, the move function is called with a value of 1.0 passed in. Now let's say instead we're pressing the S key, which has a scale value of -1.0. This means that every single frame, the move function will be called and -1.0 will be passed in. Now, in the case where we're pressing both W and S, then both of these values are added together. So we get the 1.0 from pressing the W key, and we get -1.0 from pressing the S key. Now these both cancel each other out, so if we're pressing both at the same time, the move function will be called with 0 passed in. So depending on which combination of keys we're pressing, we'll get a different value passed into our move function, and we can do whatever we like with that value, such as use it to move the pawn. We'll talk about actually moving the pawn soon enough. For now, let's just work on actually setting ourselves up so that we can handle this information from the axis mapping system. Okay, so now that we know how the axis mapping works, it's time to create a callback function that we can bind to the move forward axis mapping. So I'm going to close Project Settings and hop back into VS Code. So here in VS Code, we'd like to create a function that we can bind to the move forward axis mapping. So here in tank.h, we can create a private function. Now, it's going to have the void return type, and I'd like to call this move. Now, it needs to have a float input parameter, and we're going to call this value. So let's take our move function and define it here in tank.cpp. I'll stick it here just under the constructor, and we need a tank with the scope resolution operator before the function name. So we have this move function, and we're ready to bind it to our move forward axis mapping. And that is done inside of a function called setupPlayerInputComponent. That should sound familiar. In fact, if we open our Explorer and go back to basepawn.h, we can scroll down and see in the public section the function setupPlayerInputComponent. We'll see that this is an override of an inherited virtual function. Now, the basepawn class does not really need to set up any inputs. And that's what this function is for, handling input from a player. Now, our basepawn class doesn't need to handle input, but our tank class does. So what we can do is take this function out of basepawn.h, but I'm going to copy it because we need it in tank.h. So copying this function, I'm going to come over to tank.h, and here in the public section, I'm going to paste it. And since we don't need it in basepawn, I'm just going to remove it from the basepawn class. And in fact, I'm going to go into basepawn.cpp and remove it from here as well. So let's go ahead and delete setupPlayerInputComponent from basepawn.cpp. And now it's no longer in the basepawn class. So let's go ahead and save our changes and close basepawn.h and cpp. And now we have setupPlayerInputComponent declared in tank.h, but we also want to define it in tank.cpp. So here in tank.cpp, I'm going to add the definition just above the move function. So this is void, and it's a tank setupPlayerInputComponent. Now let's go back to tank.h and see what its input parameter type is. You'll see that it's forward declared here inside the parentheses. This is something you can do if you want to forward declare a class type in a header file. So it's forward declared here. And we need this uInputComponent pointer type, and the parameter is called PlayerInputComponent. So we need this input parameter in tank.cpp. So in the parentheses for setupPlayerInputComponent, we're going to have a uInputComponent. That's a pointer, and it's called PlayerInputComponent. So now the function signature matches that in the function declaration. Now, back in the CPP file, let's give this function a function body. And we're overriding this function, and it's a good idea to call super setupPlayerInputComponent. Now, since we're calling the parent version of setupPlayerInputComponent, we have to pass in an input of type uInputComponent. We're going to pass in the input parameter to this function here. So this way, the parent class will call its version. Now, the basepawn tank is not implementing this function. We just removed it. But the parent class to basepawn will call its version. And whenever you override a virtual function like this, calling the super version is a good idea so we don't miss any functionality implemented in the parent version. So why are we doing this? What is setupPlayerInputComponent good for? Well, one of the things it's good for is binding functions to axis mappings. We'd like to bind our move function to the move forward axis mapping, and we do that here. We do that using this input parameter PlayerInputComponent. That's what this object is designed for. We take the PlayerInputComponent, and on this pointer, we use the arrow operator to access a function called bindAxis. Now, bindAxis takes a few input parameters. The first is a string literal, which means we're going to use the text macro. Now, what do we put in the quotes? We put the name of the axis mapping. We saw in the editor that this axis mapping is called move forward. So we're choosing that axis mapping to bind to. The second input parameter, this is going to be a pointer to the object we're binding the function for. This is a pointer to the instance of the particular class we're in. And since we're in the tank class, this will point to the instance of the tank pawn in the game. Now, the third parameter is the address of the function we're binding. So we have a tank move Very important that we need to fully qualify the function name with the name of the class. And right here in front of the function name, we need the address of operator. Now, if you're not familiar with doing something like this is simply taking the address of a function. Functions can have addresses just like variables can. So using the address of operator is a way to pass functions into other functions. So that's why we need that address of operator. So we have our function call to bind access. Now you're probably noticing the IntelliSense error pointer to incomplete class type uInput component is not allowed. Now we know what can cause this. For one, it could mean that we need to include a header file. Another possibility is that it's a false error. You can easily find out by compiling. So let's attempt to compile. We'll see that we have a successful compile, so we know this is a false error. But again, if you want, you can add the include just to remove that so it's not bothering you. Now we know that the class type that it's complaining about is uInput component. So here's uInput component in the documentation, and here's the include. And if we add this up here at the top of the tank CPP file, we'll get rid of that pesky false error. And again, because these have the pragma once include guards, we know that input component.h is not going to be included more than once. And there go the squigglies, they're gone. So now we know this move function will be called every frame, and value will have a particular float value, depending on whether we're pressing the W or S keys. Now, simply knowing that the move function is bound to move forward is not quite enough. As developers, it's nice to have some sort of confirmation that things are working. So what I'd like you to do as your challenge is to use uilog in the move function to print the value that's being passed into move, that float called value. So use %f in uilog to log the value of the float value to the output log, and then playtest the game and press those keys and see what you get printed out to the log. Pause the video and add this to the move function now. Okay, so here in the move function, I'm going to add a uilog. And this can be log temp, warning, and for the text macro, I'm simply going to put value, %f, and value. Now that's okay if you used a different verbosity or warning type. If you know how to do those things, that's totally fine. I'm just going to use a warning here. And I know you've used things like %s and formatted your log with a string value. %f, if you're not aware, is how you can format your uilog with a float value. So let's compile this. And back in the editor, I'm going to open up the output log and press play. And check it out, we're spamming the output log with countless messages. Now I'm going to click in the viewport and press the W key. There's my value of 1. I'm going to release. It's back to 0. I'm going to press the S key and it's -1. And if we press both at the same time, we get 0. And so it's exactly as we expected. Perfect. All right, so in this video, we've set up our pawn to handle some user input. We talked about access mappings, and we bound our move function to the move forward access mapping. We then printed that access value using uilog in our move function. But we'd actually like to move our tank rather than just print some values to the output log. So in the lectures to come, we're going to set it up so that we can actually start moving our tank. I'll see you soon.